All right, now we're going to look at the different plasma concentration of our gonadotropins throughout the adult's lifetime, right? We're going to look at specifically male and female, right? So while we're looking at this, we're looking at different concentrations of luteinizing hormone and follicular stimulating hormone on the bottom, right? On the bottom, this is the time of the lifetime, right? So you have C for childhood, P for puberty, A for adulthood, and then this is for menopause or manopause or andropause, right? So this is, we're just trying to look at what's going on here. So before we get started, if you remember, in the hypothalamus, specifically the anterior pituitary, are regulators of these steroid hormones, right? So you have the hypothalamus here, you have the anterior pituitary here. And so if you remember, the anterior pituitary, the hypothalamus secretes GnRH, it's gonadotropin releasing hormone, comes in through the hypothalamic hypophyseal portal system into the anterior pituitary, stimulating the gonadotrophs of the anterior pituitary to secrete FSH and LH, so follicular stimulating hormone and luteinizing hormone, to go down to the gonads in order to secrete sex hormones. So sex hormones here, we're going to talk about testosterone and estrogen and progesterone, right? And so the basic point of this lecture is just to show you the concentration of the gonadotropins, right, the LH and the FSH, and how they change throughout the lifetime of the baby. The baby, which eventually becomes the man, right? Man or woman, okay? So when we look at childhood, for both plasma FSH and plasma LH, the gonadotropin, so gonadotropin is what? So again, just in case you guys are getting confused, FSH and LH, also another name for them is gonadotropins, right? Hormones. Right, so all the hormones from the gonadotropin cells, these are all LH, FSH, all right? Now, when we look at the concentration, right, so the y-axis is showing the concentration of LH, and then the x-axis is showing you the age of onset. During childhood, before puberty, so prepubescent, you have a very low level of luteinizing hormone and follicular stimulating hormone, right? So it fluctuates up and down, right, because it's not steady. So it's up and down, because remember, hormones are released in pulses, right? They're not basically secreted in a very consistent manner. So pulses up and down, up and down. And eventually, whenever you hit puberty, then you have sort of a skyrocket, right? You have this increase in concentration of tropin hormones. These gonadotropin hormones, right? So at puberty, luteinizing hormone and follicular stimulating hormone spike, right? You have these hormonal changes. Now you have all the sex hormones coming in, right? So your estrogen, testosterone, and progesterone, right? So these are all, we're not talking about a selective person, we're just talking about sex hormones, begin to increase, right, during puberty, right? Now, during adulthood, when you reach adulthood, so after puberty, around after 18 to 21, this concentration of tropin cells, gonadotropin cells, are maintained at a linear level. They're plateaued now. They do not increase, decrease, right? So you have this spike at the puberty, right? So all the pituitary hormones spike, right? So the LH and the FSH spike, and so now this plateaus throughout the entire adulthood, right? Now, whenever you begin menopause or manopause, so female or male, there is a change in this luteinizing hormones. And so based off of this mechanism, if you remember from before, what was the actual regulation patterns of these hormones, specifically in the hypothalamus and in the anterior pituitary? How are they regulated? What type of feedback loop? They're regulated via a negative feedback loop, right? In order to maintain the homeostatic concentration of these steroids, right? You don't want to have too much or too little. This is regulated via a negative feedback loop. And what regulates it? based off of negative feedback loop. What's the definition? When you have a stimulus, this causes an inhibition. The stimulus is the sex hormones. When the sex hormones are high here, this causes the hypothalamus and the anterior pituitary to stop secreting their respective hormones in order to bring this concentration back down. And this is a continuous cycle. But what's really important too, remember, a negative feedback loop, a stimulus causes a response. In a negative feedback loop, the stimulus causes an inhibition, right? Steroids, these steroids, estrogen, testosterone, progesterone, cause an inhibition, right? But during menopause and menopause, what did we say before in the previous lecture? That the gonads, the ovaries and the testes, become fibrotic and they begin to degenerate, they begin to atrophy, right? So these, during menopause and menopause, these hormones become inhibited, as in they're not created anymore, right? So what do you think would happen to the concentration of luteinizing hormone and follicular stimulating hormone? If you guessed increase, you are correct, right? So there would be an increase in concentration of follicular stimulating hormone and luteinizing hormone. Why? Well, remember, at menopause, we'll just put a big M in it, there is no more sex hormones. No more sex hormones, no more inhibition via negative feedback loop. So these hormones, gonadotropin releasing hormone, follicular stimulating hormone, and luteinizing hormone are unregulated. And because they're unregulated, they just begin to continuously be secreted, right? And so that's why after menopause, a great way of indicating whether if you're going through this change is to look at your gonadotropin hormones after the age of onset, right? So you wonder like, okay, I got hot flashes. Do I have menopause? Am I going through menopause or menopause? What's going on, right? Easy way is just get a blood test and test your FSH and LH levels. If they're significantly higher than they were before, then it's probably that you're going through that significant change.